On to chapter 4, section 3, writing equations of parallel and perpendicular lines. Did you guys ever talk about parallel perpendicular lines in pre-algebra?
I think so.
Do you guys remember what's special about parallel lines and what's special about perpendicular lines?
Parallel lines always run evenly with each other but never intersect.
Very good. They're just always going to be straight across from each other. They're never, ever going to touch. Correct?
Yes.
Do we know anything else special about them? Do what? I'm sorry, say it again.
I thought you were going to ask for perpendicular.
Oh, gotcha. Anything else special about parallel lines besides that they never intersect? Okay, what's special about perpendicular lines?
They make a 90-degree angle and they cross.
Very good. They cross at a 90-degree angle. So don't get that confused, perpendicular lines with just lines that intersect, because not all lines that intersect are perpendicular. For them to be perpendicular, they have to cross at 90 degrees. They make 90-degree angles when they cross. Yes?
The x and y-axis is a perpendicular intersection.
Yep. My x and my y-axis are perpendicular lines because they create these 90-degree angles. Does everyone kind of remember that from pre-algebra? All right. Well, let's talk a little more in depth about them. We're going to learn some more things about parallel and perpendicular lines, specifically things about their slope. What is slope again? Well, that's slope-intercept form. What over what? Rise over run. What's my slope formula?
That's not one. Y2 minus y1 over x2 minus x1.
Y2 minus y1 over x2 minus x1. So we might have to use that a little bit today, possibly. Okay? So let's talk about parallel lines and their slopes. We already discussed this. Two lines in the same plane that never intersect are parallel lines. You guys already knew that information, correct? Parallel lines never intersect. They never touch. Two distinct non-vertical lines are parallel if and only if, what does that last part say? They have the same slope. You need to know this information. Write that down. Two distinct non-vertical lines are parallel if and only if they have the same slope. So if two lines are parallel, that means they have the same slope. If two lines have the same slope, they're parallel. So remember, the parallel lines have the same slope. Which makes sense, right? Because they're never going to intersect. So I want them to have the same rate of change as each other. That way they never intersect. And just a little side note, all vertical lines are parallel. As well as all horizontal lines. Those are all parallel as well. Any questions about parallel lines and their slopes? Does that make sense? Parallel lines have the same slope. Lines that have the same slope are parallel. Not too bad, right? Can I move on, or are we still writing? All right, moving on. Example 1. Determine which of the lines are parallel. So I could try to guess at which lines are parallel here, just based on the looks of them. But that's not always going to give me my most accurate answer. Because it looks like all of these might be parallel, right? How am I going to know if they're parallel or not, though? They got to see if they have the same slope. So I'm going to find the slope of each of my lines, A, B, and C. See which slope they have and decide which ones are parallel, if there's any that are parallel. So there's two ways I could find the slope here. I could either just use my rise over my run, do my rise over my run, or I could use that slope formula we talked about. So on line A, which method do you want to use? You want to use rise over run or the slope formula? Rise over run. Let's use rise over run. So how far am I rising to get from that point to the next point? negative 1 because I'm going down. So I'm going to say slope of A. So it'd be negative 1 over, how far do I run? 5. 1, 2, 3, 4, 5. So my slope of line A is negative 1/5. What does slope dude say on that line? Nice negative, so I have the sign correct. It's negative 1/5. Questions on slope of line A? For letter B, let's go ahead and use our slope formula just to get some more practice with that. Gives me two ordered pairs here. So what's my y2 value? Negative 1 minus, what's my y1? 0 over, what's x2? 1 minus, what's x1? What's negative 1 minus 0? Negative 1. And this is 1 plus 3. What's 1 plus 3? 4. So, what can I conclude from just finding these first two lines? Are these two lines parallel or not?
No.
Nope. Why? They do not have the same slope, so I know they're not parallel. They will eventually intersect somewhere up here. Questions on the slope of line B? Bless you. Okay, which method do we want to use on line C? Rise over run or slope formula? Rise over run. So slope of C. How far am I going to get from this point to this point? Rising. Negative 1. How far am I running? 5. That's not a very straight line, I apologize. So what can I conclude about lines B and C? What? They are not parallel, are they? A and C are parallel. And why do I know they're parallel? Same slope. So I'd say lines A and C are parallel. Because they have the same slope. So that'd be me determining which of the lines are parallel. And then if it asked you to explain it, this would be your explanation. Because they are parallel. Or because they have the same slope, I mean. Any questions on example 1? Everyone good there? Moving on. Example 2. Writing an equation of a parallel line. Write an equation of the line that passes through 5, negative 4, and is parallel to the line y equals 2x plus 3. Can anyone raise your hand and help me figure out how I'm going to approach this? Can anyone help me out here? How am I going to come up with an equation of a line that goes through that point and is parallel to the line that I'm given? Anyone have any thoughts or ideas that we could try out real quick? Yes? Why would I use point slope form? Why do you think I would? Why are you throwing that idea out?
Because you gave us a point and then you gave us the whole other equation instead of just two equations.
So where's the slope coming from?
The other equation.
How do I know I get the slope from the other equation?
Because that's slope form. There's slope-intercept.
That is slope-intercept form. But what it's telling me it wants it to be what to that line? Parallel. So I know I'm going to have the same slope as that line, right? So you're exactly right. We're going to use point slope form. Because I'm given a point, I'm given a slope here. What is point slope form again?
I don't know the right side.
There it is. So what's my parallel slope that I'm going to be using? 2. And then there's my point, 5, -4. Does everyone see how we have our point and how we have our slope from the information we're given? So, what's my y1 value? -4, so it's going to be y plus 4. What's my slope? 2, because it's parallel to the line that's given. So I'm using the same slope since they're parallel. And then what's x1? 5. Once again, I'm going to reiterate this. It wants us to write a line that's parallel to this line. So since it's going to be parallel, it has to have the same slope. So the slope of that line is 2, so I'm going to use the slope of 2 as well. And let's go ahead and get this into slope-intercept form. What do I need to do first? Distribute. What's 2 times x? 2 times -5. And then now I subtract 4. So I get y equals 2x minus 14. And there would be my equation of the line that goes through this point and is parallel to the line y equals 2x plus 3. Any questions on that? Everyone see how we process that and work through it?
Do you mind if I take a second to write all this down?
Yep. I'll give you some time. So remember, to write it in point-slope form, all you need is a point and a slope. So we use the information we were given to use our point and a slope to plug into point-slope form. Now, if this point was a y-intercept, what form would I have jumped to automatically? Slope-intercept form, because I could have used the slope from here, and then boom, I already have my y-intercept. What would the order pair look like if it was a y-intercept? X would be 0, 0 comma some number. That's how you can tell if it's a y-intercept. Any questions? Can I go ahead and move on? Yes, no? And this is not an 11 next to my slope. If you have 2 lines next to each other like that, that just means parallel. So that's why I said parallel slope. Mine does kind of look like an 11 though, I apologize. Yeah, that just means parallel. Here, I'll try to fix it.
You can put little arrows at the end.
Is that better? Kind of? No, that's worse.
So just create a symbol that says parallel.
There you go. That'll have to do.
Yeah, those are the intersections in the point.
Okay, moving on. We're not going to sit here and judge my parallel lines. Okay, now let's talk about perpendicular lines and slopes. So, do you think perpendicular lines are going to have the same slope?
No, they're gonna have reverse at the same time.
Anyone have any idea what the slopes, how the slopes would compare?
Oh, it's a horizontal and vertical, it's undefined in 0. They have to be inverted, right?
Inverted? Yeah. What do you mean by inverted?
Factor of -1 to each slope.
Say that again.
Like you factor -1 to the slope to find the other one.
One's going to be positive, one's going to be negative.
Or it's undefined in 0.
Yep. Those would be perpendicular. Let's just look at it. 2 lines in the same plane that intersect to form right angles are perpendicular lines. So once again, for them to be perpendicular, they have to form right angles when they intersect. Non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. I don't use the word negative whenever I'm talking about perpendicular slopes. I use the word opposite. They're opposite reciprocals of each other. Because sometimes y'all think that it has to be negative every single time. But if I'm starting out with a negative slope and it wants it to be perpendicular, it's actually going to be positive. So I just say opposite reciprocal. That way we don't get confused. Vertical lines are perpendicular to horizontal lines, like you were saying. So does everyone know what a reciprocal is?
Yes.
How do I take the reciprocal of a number?
Times it by itself, or
Not quite. If I multiply a number by its reciprocal, I'll get 1. But how do I take the reciprocal of a number? I flip it. So here, this blue line has a slope of negative 2. Well, what's negative 2 as a fraction? Negative 2 over 1, right? If I flip that, what do I get? Negative 1/2. And then what's the opposite of negative? Positive. So the opposite reciprocal of negative 2 is positive 1/2. Does everyone see what I mean by that? The reciprocal is talking about flipping the fraction. The opposite is about changing the sign. Does that make sense? So perpendicular lines will always have opposite reciprocal slopes. So if you're wanting to find the slope of a line perpendicular to the line you're given, take its slope, flip it, change its sign. Everyone good with that?
So we just throw 1 in there and it's good.
If it's a whole number, yes. Now, sometimes you might get a slope that's like 3 over 5. What would the reciprocal of 3 over 5 be? 5 over 3, and then the opposite would be negative 5 over 3. So if it's already a fraction, you just flip it. If it's a whole number, you put a 1 under it, flip it. Or if you start off as 1/2, you flip it, it becomes a whole number.
So 4 would be negative 1/4.
Yep. And 1/4 would become negative 4. Any questions about perpendicular lines and their slope? Just remember, you have to flip the fraction and you have to change the sign. And I'm going to be using the word opposite reciprocal, like I said, instead of negative reciprocal. Can I go ahead and move on, or are we still taking some time to write? I'll take that as I can move on. Okay, example 3. Determine which of the lines, if any, are parallel or perpendicular. So it gives me 3 equations of 3 lines. What form do I want it in to be able to identify the slope? Huh? Slope intercept, yep. So let's get all of these into slope intercept form. Is line A already in slope intercept form? Yep. What's my slope of line A? 4. Very good. What do I need to do to line B to get it in slope intercept form?
For y specifically,
Say that again.
you need to get y alone.
Get y by itself. So what's my first step to get y by itself on line B? Not minus 4. I mean, you could do that, but you're adding an extra step if you do that. Well, let's move that x first.
minus x.
Minus x. If you divide by 4, you're going to have to divide everything by 4. So let's get everything to one side before we start dividing. And now, what can I do with that 4? Divide everything by 4. So I get y equals negative 1/4 x plus 3/4. So what's the slope of line B? Negative 1/4. Okay, line C. Let's go ahead and identify the slope before we start comparing all of our slopes. What's my first step to get y by itself? Add 2x to both sides. I get negative 8y equals, that's an x, 2x plus 16. And what's my last step to get y by itself? Divide everything by negative 8. So y equals, what's 2 over negative 8 reduced down to? Negative 1/4 x. And then 16 divided by negative 8? Minus 2. So what's my slope here? Negative 1/4. All right. So let's start comparing our lines. Do I have any lines that are parallel? Why are they parallel? They have the same slope. So I can say B and C are parallel. Do I have any other sets of parallel lines? Do not, do I? Do I have any sets of lines that are perpendicular?
Yes. Line A with literally any of them.
Line A is perpendicular to both B and C, correct? So I can say A and B are perpendicular, and A and C are perpendicular. Do I have any other sets of perpendicular lines? Nope. That's about it. I've identified all the ones that are parallel, all the ones that are perpendicular, correct? Why is line A perpendicular to line B and line C?
Because if you were to write it out, it'd be 4 over 1.
Yep. My slope on line A is 4 over 1. So what's the reciprocal of 4 over 1? 1 over 4. And then the opposite of positive is, so the opposite reciprocal of 4 over 1 is negative 1/4, which is the slope of both of these lines. So I know that A is perpendicular to both of them. Does that make sense? Any questions on example 3? Not too bad? Get your heads up, please. Wake up. Can I move on? Last slide. Example 4. Write an equation of the line that passes through negative 3, 1 and is perpendicular to the line y equals 1/2 x plus 3. So this is very, very, very similar to the example I just did a few slides ago. So can anyone raise your hand and help me out on this one?
So put it in the point, the point slope thing. Then because you need a perpendicular line, do the opposite reciprocal of 1/2.
What's the opposite reciprocal of 1/2? 2 over 1 is the reciprocal. Negative 2 over 1, or just negative 2. So this symbol, the upside down T, represents perpendicular. Because if you see it, forms a right angle. So if you see that, just know it means perpendicular. If you see the two lines next to each other, just know that means parallel. So my perpendicular slope is negative 2. So I know my slope. I know a point that I'm going through. So I can use point slope form once again. So what is my y1 value? 1. What's my slope again? Negative 2. Do not use 1/2 because they're not parallel. They're perpendicular. And then what is x1? Negative 3, so it becomes plus 3. Everyone good? Plug it into point slope form. Let's get into slope intercept. So what's my first step? Distribute. Negative 2 times x. And negative 2 times 3. Negative 6. And my last step to get y by itself. Add 1 to both sides. So I get y equals negative 2x minus 5. So here is my line that passes through the point negative 3, 1, and it is perpendicular to the line y equals 1/2 x plus 3. Are there any questions on that? Does that make sense how we approach this problem? Make sure you're aware on what it's asking. Make sure you're aware if it's parallel or if it's perpendicular. If it's parallel, you got to use the same slope. Perpendicular, you got to use the opposite reciprocal slope. Everyone good with that? Any questions, comments, concerns? Can I move on? Okay, I'll give you a second. We good? Here's our assignment. Pages 195 through 196, numbers 2 through 30 evens. Get your head up. 195 through 196, numbers 2 through 30 evens. What is today? Tuesday the 13th. This will be due on Thursday, the 15th. On Canvas. Due Thursday, April 15th on Canvas. Tax day. So when everyone's taxes are due. So it's when your homework's due too. Are there any questions about any of the notes we just took before I end the recording? All right.